Okay, so diving into lesson 1.1, modeling and equation solving. So we are looking at just solving various problems, whether it be numerical problems, like these first couple we have tables were being provided and answering some questions based on the tables. Some very basic, some that's going to take a little bit more insight. We're going to look at making some models, looking at the graphs and seeing, how those numbers are, making the graph look and whatnot. And then we're also going to, at the end, do some solving equations, both algebraically and graphically. Okay? So, mathematical model. A mathematical structure that approximates phenomena for the purpose of studying or predicting behavior. So, just math, right? We're, looking at some type of situation to study the behavior. We're going to start with the numerical model, the most basic kind of mathematical model in which numbers are analyzed to gain insights into phenomena. Thus, we're looking at a table. So you have a table there, table 1.1, minimum hourly wage. The numbers in the table show the growth of the minimum hourly wage from 1955 to 2005. The table also shows the minimum wage adjusted to the purchasing power of $1996. Answer the following questions. So, in what 5-year period did the actual minimum wage increase the most?
65 to 70. I lied.
Yeah, not 1975 to 1980.
No.
85 to 90.
80 to 85. No.
80 to 85.
I'm so
Yes,
wrong.
that is the most.
So
85
one of those
to
are
90.
four.
85 to 90.
15 cents,
So,
25 cents.
right?
That's what makes the most
It's
sense.
85 to
75 to
90.
80.
Yeah,
Yeah, it's 85.
that's
Is it 75 to 80?
85
it's a dollar egg.
No, 75 to 80
Oh,
is
no,
a
yeah,
whole dollar.
Yeah.
$1.25.
It's been a long week.
I was gonna say that's a whole dollar.
I'm not even half asleep.
I am.
It's just been a long week.
Okay, guys. So, we've all looked and re-looked about a bazillion times already in this chart.
75 to 80 was my original choice.
Okay, so in what 5-year period did the actual minimum wage increase the most? And you are supposed to be noticing 75 to 80 because there is a dollar increase. Yes, a whole dollar.
We're supposed
As
to be.
opposed to the others that none of the others are ever more than $1. They're always less than $1. Just goes to show how hard a chart like that is, you have to really break it down. You almost have to go through and subtract each and find those gaps.
It plays tricks
So,
with your eyes.
and it does. Now, do keep in mind, you do have that chart right in front of you on your desk. So you don't have to stare at the screen and try and make it make sense on the screen.
Oh, I looked at the chart. I just.
I had several people that were trying to stare at the screen.
I
and
stared at the
I
screen.
know that was part of the
At
problem.
least that.
I know.
Yeah,
You're in the front row, though, too.
It was worth $1.
Okay. B. In what year did a worker earning the minimum wage enjoy the greatest purchasing power?
Okay, this is 1970.
1960.
Well, if you go by the purchasing power of 1956, it's 1970.
Mario, what are you thinking?
Why do I have that?
Either 1960 or 1970. One of those.
2000.
Well, it says, what year did they enjoy the greatest purchasing power?
It would be 1960.
Over here in the right, purchasing power in $1996. So purchasing power,
It's the biggest number.
you're looking at
It's 1970.
1970.
It is. I was going to say 1960.
You guys are really overthinking this.
I did.
I do that.
Okay.
Biggest number.
I'm really good at doing that.
C. What was the longest period during which the minimum wage did not increase?
What? No, it said.
So the longest period would be a period of 5 years. And that is according to this chart, right?
It's very. This chart is made by experts.
Okay. Obviously, 2005, it's 515. What was it in 1999? What was it in 2006? This chart only goes every 5 years. So
We just
based on this chart, 5 years. Okay. D. A worker on minimum wage in 1980 was earning nearly twice as much as a worker on minimum wage in 1970. And yet, there was great pressure to raise the minimum wage. Why?
Due to
Inflation.
Purchasing.
Okay. So what do you notice? In 1970, the purchasing power was 647, whereas in 80?
Yeah.
In 1980, the purchasing power is only 590. So even though you're making more, your money's not going as far. That's kind of the way I think of it. Okay, it's probably more of a Mrs. Fernand question, but you know,
Which is even more of an issue.
Purchasing
like,
power.
scheme of things, because then like that brings inflation, and then it's like
What does purchasing power mean?
it's just such a mess, and I don't understand like the U.S.
purchasing power
What does
being
purchasing power mean?
so purchasing power being what you can get for your dollar. You know,
Then
does
why is it?
a dollar get you a candy bar, or does it get you 3 candy bars?
My dollar gets
Like
me
back in,
$5.
Or does it not even get you a candy
Back
bar?
in like 1940, you could get like 4 bars of chocolate for like 5 cents, but you can't do that anymore. Unless you know
90
right
cents
now.
for a gallon.
No, at the Sharp Soul gas station, sometimes they'll like round down, or they'll
It's
give you
so
extra
nice.
change, and it makes my day.
You charged me full price for this little hot Wheels car. And it came with the chocolate.
Okay, so on here, I wrote down the fact that the purchasing power was decreasing because, you know, even though minimum wage is going up, your dollar is not going as far.
So if
Okay.
it's decreasing, that means things cost more.
Let's go look
If
at
it's
Right.
increasing, that
1970.
means things cost less.
You can get more for your dollar. Okay.
So put on a parachute.
I learned something new today.
What's the minimum wage now? Is it like
Like
$7.25?
I honestly don't. I have no idea.
I get paid $8.50.
But you won't find anyone with 750 because
In this state.
the least they'll charge you. The least they'll charge you is
$7.50?
$8.50.
I honestly have no idea. Yes.
The minimum
Okay.
they'll pay you though is $8.50.
Okay, guys. I know we want to have a chill Friday. However,
We gotta work with it.
I'm struggling to get through anything. So
Hey, we-
let's focus the conversation on where I need it to be, please. Okay. Example 2. And this is where I said have your calculators out because we're going to explore something we can use the calculator to do. The table to the side shows the growth in number of prisoners incarcerated in state and federal prisons from 1980 to 2005. Is the proportion of female prisoners over the years increasing? So do you notice, what did they ask?
Portion.
Proportion of female prisoners increasing. Keyword there being proportion. Can't I just look at my list of female prisoners? Is that a proportion?
No.
No.
Do like the fraction thing.
Yeah, so this is saying, okay, in 1980 there's 13 female prisoners. In 1985 there's 23. The number of female prisoners is increasing. But if we're talking proportion, what do we have to do? We have to look at it in comparison to
The
total number of prisoners, right? So we need to, yes, we're going to examine, you know, female prisoners, but is it increasing along with the total? Is it increasing more than the total? Is it increasing less than the total? Now, you have options here. One option is you can take that calculator and you can divide all these by hand, yes? And in all honesty, that's going to be quicker than what I'm going to teach you. However, I want to show you a way to introduce and use tables on your calculator so that you can, once you have all this data entered, you can just enter the division once and it does it all for you. Okay, so if you will, grab your calculators out. Let me get switched over here. Okay. Everyone has a calculator out, right? Everyone Everyone has their calculator with them. So, first thing we're going to do is we have to enter this data, right? So, spin a bit. Is that where I want to go? Yes. Okay. Edda, you're going to want to look for something where you can enter a list of numbers. Okay? I'm not sure where to tell you to go in your calculator. Okay? So, kind of listen to what we say and see what you can figure out. For the rest of you, though, right here, on the same row as your green alphabet, is stat. And so I'm going to take, you can also go into second list, but I'm just going to take you in through stat. And so you have some options here, yes?
Yeah.
You can edit, you can sort, you can, do all this stuff. So we're going to go into edit, because we're going to edit a list. And you're going to bear with me while I clear my columns out. So you have L1, L2, L3, L4, L5, yes? Now, if you have numbers in those, you can clear them out by going up to the top and hitting clear and enter. But we're going to enter these numbers. Now, first number we need to talk about, we definitely need to include female, yes? So I was going to have us enter the female numbers in list 1, L1. And I'm going to have us enter the total numbers in L2. If we knew we needed to enter the male numbers, we could enter those in a list too. So, in my L1, I'm going to enter 13, enter, 23, enter, so on and so forth.
Miss Sarge, what are you doing since you're in radiant still?
That will have nothing to do with this.
Oh, okay.
Just got it.
So I have my numbers in my L1 column. I'm starting with 329, putting my total numbers in my L2 column. Doesn't hurt to recheck that you typed all your numbers correctly. And I get it. If we just divide all these numbers by hand, we'd already be done quickly. I understand that, but this is a tool that can be used for lots of different things, so that's why I'm trying to introduce it to you. Okay. You have your numbers entered. I know I didn't skip any numbers because my lists are the same length, right? So, mathematically, what do we have to do here? We need to take female, right? And divide it by total. Which means, what are we doing here? My females are in list L1. My totals are in L2. So it's the idea that I have all my female numbers in L1, right? And I was just, so all those are in female. In L2, I have all my total numbers. I'm not going to bother writing them down because they're in my calculator. But what do we need to do to get our proportion? We need to do what? We need to take L1 divided by L2, yes? Mm-hmm. So what we're going to do is we're going to go over, and where do we want those numbers to land? Well, I have L3 sitting there open, yes? So what I'm going to do is I'm going to set it up so that L3 is equal to L1 divided by L2. That's what we're going to set up here. So, if you go over to L3 and go up into the heading, don't be in the first column. You see how I'm up in the heading of L3? And then I can type in L1 divided by L2. So if you'll notice L1, L2, all those, they are the second function above like the 1, 2, 3 buttons. Do you see that? We're seeing where I'm at?
Yeah.
So down here is L1, L2, L3. They're above the key, so it's a second function. So up here where it says L3, I can do second, L1, do my divide by sign, and then second, L2. When I hit equals, my L3 is going to have all my answers.
That's it.
And our answers should match.
Is there a reason that yours has 5 decimal places, and mine only has 4? Is that like a big deal, or?
No, and I think what I've discovered is that's my calculator that's on an older update. And I bet if I used this calculator, it would probably have the same decimal places. Because I discovered that in one of my classes the other day.
Mine has 4.
So, okay, so what's mine has 5. What do your guys' have?
4.
4. Okay. So now, like for my first one, I have 0.03951.
Ours is only 0.
Some of you have 0.0395. Some of you have 0.03951. Realize that's the same, isn't it? I mean, at that point, you're talking about the 5th decimal place. Not a huge deal. Okay. Now, the nice part about this, I have all my data in order. You know the answers to the question before I even write this information down. Is my proportion of female prisoners over the years increasing? Yes. Because at first it's, if you turn those into percents, what? 3.9%. Then it's 4.5%. Then a little over 5.5%. 6%. Over 6.5%. 7%. So it's increasing at least 0.5% per year, isn't it? Okay. So I'm going to write those numbers down, just so we have them in your paper. Write your numbers down, write my numbers down, whatever. So 0.03951, 0.04582, 0.05685, 0.06044, 0.06686, 0.07077. So, is the proportion increasing? Yes, and I'm going to say, as shown in L3. So that's one small way we can use list. Okay, there's lots of different ways you can use it, but that is a small. Okay, now that could really be helpful with a really long list of numbers, yes? Or if, okay, now we're going to do something else with the same list of numbers, right? Obviously, again, I understand. Some of you are saying, that was stupid. I did that. I had that done before you ever showed me lists. I get it. Not going to argue. But trying to introduce you to a function on your calculator as well. Okay. Questions on that? Okay. We will continue to look at lists. We're going to use our list down when we get to example 4. But for the moment, we're going to look at example 3, algebraic models, a mathematical model that uses formulas, equations, right, to relate variable quantities associated with the phenomena being studied. We can then generate numerical values of unknown quantities by relating them to known quantities. Key word. We're talking, there's some kind of formula here. And so as you look at example 3, a pizzeria sells a rectangular 18-inch by 24-inch pizza for the same price as its large round pizza, 24 inches in diameter. If both pizzas are of the same thickness, which option gives you more pizza for the money? Where do you get more for your dollar?
I think we have to experiment with this.
We need the experiment of we need the physical pizza in here to experiment
I'm gonna
with,
say
don't we?
spread pizza, more surface area.
We have 14 and 10 inches.
Okay, there we go. So,
I can do the
Okay.
measurements and take
now,
the
I heard
measurements.
someone, other than doing the exact experiment, which even then has its flaws, we need to compare what?
Surface area.
Okay, we need to talk about this area here. We need to talk about, now they have the same thickness, so we don't have to worry about if one is a thin crust and one is a thick crust. We're talking same thickness pizza here. And let's see. We have a rectangular pizza. What do you know about a rectangular pizza?
More surface area than the circular.
Not
Area
necessarily.
equals length times width.
Okay, rectangular pizza. In order to find the area of a rectangular pizza, we're going to do length times width. And the length and width of the pizza were 18 and 24. I'm technically I'm just doing area here because I'm just worrying about what it includes. I'm not worrying about the thickness. What is 18 times 24?
432.
So officially the area of my rectangular pizza is 432 inches square if you want to get official with your labels. And then we also have a round pizza. What do you know about a round pizza?
It's got triangles. Place to square house.
What do we know about round pizza here?
Isn't the area of a circle like pi or
Pi r squared.
Okay. So first of all,
That's not really true.
yes, you do need to pull your circle formula. A equals pi r squared. And let me state for the record, you're in pre-calc. That's a known formula. Okay? And I know there was lots of isn't it?
I still don't.
That's a formula we need to know. Period. You know, just like you know the area of a rectangle. At least I assume we all knew that one. Area of a circle? That should be right up there by this point in your life. You've been doing area of a circle since middle school at least, so. Okay,
No, I couldn't find it. I was looking for it.
what is pi? Approximately 3.14. Radius, r. What's my radius?
12
12, and it's going to be 12
squared.
squared. Is 12 squared 24?
No.
No. Silly question, but it's a question I have to ask. First of all, if you're still in list and you're trying to get out, you can always do a second quit, which is what I tend to do. Did you guys all find your pi button for when you need it?
Yes.
Yeah.
It is second of the exponent button. Or you can type 3.14 for this, and then you can just type times 12 squared. And I used the pi button and got 452.39. Did anyone not use the pi button?
Yes, 452.6.
Okay. You're not wrong if you got 452.16. Because then you just use the approximation of 3.14. Okay, so but they're both around 452. In the big scheme of things, doesn't really matter for what we're doing because which option gives me more pizza for my money? I want to order the round pizza, don't I?
Now pizza.
Oh my gosh.
Now I just made everybody hungry.
Pizza does.
I want pizza.
Pizza always
Might as well
sounds
buy
good,
it.
so.
I
If we all
don't
get
know.
something
Now
like
I really
If we average like an 89.5 on this test, we should get like a pizza.
you
Well,
scored
we're
it
collectively drinking. Yes.
Okay,
You have
guys,
to get a
moving along,
Fair trade.
trying to keep us on track here. Okay, so that was just an example of an algebraic model. Just using formulas we already know to do the math. Now, what we're really going to spend some time on here is graphical models. And that is a model that gives a visual representation of the numerical algebraic model and gives insight into the relationships. So, Galileo spent a good deal of time rolling balls down inclined planes, carefully recording the distance they traveled as a function of elapsed time. His experiments are commonly repeated in physics classes today. So, I know you guys just recently went and dropped balls from the top of the bleachers, right? So, okay.
I still haven't finished that one.
Okay, so it's easy to reproduce a typical table of Galilean data. Now, the question, what graphical model fits this data, and can you find an algebraic model that fits? So, we want to think graphically here. And we have an option. We could grab a piece of graph paper and we can graph these by hand, yes? And we can kind of look and see what kind of model, what kind of shape these points are making. Or we can graph these points on a calculator. Now, at this point in your life, most of you, if not all of you, what do you know how to graph on a calculator?
Like,
Okay? Or as long as it's y equals, right? You can graph an equation. Do I have an equation?
nope.
No. Now, and in fact, it says, can you find an algebraic model? We'll talk about that here in a little bit. Okay, if we can find an algebraic model. But we're going to first worry right now about a graphical model. So, let's go to our calculators. Now, do you remember how I got us to the list earlier? Because we're going to use the list and put our data in the list, and then we will graph it. And then we can graph points. Make sense? So first of all, to get to the list, I went into stat. Honestly, what does second list take you to? So second list, you can go straight to and pick which list you want to go into. Yeah, no, I don't want that. Okay, we're going to go into stat. I'm going to go ahead and hit enter into edit. Now, do I still need these same numbers at L1, L2, and L3? No. And I believe, what, you can delete them each by hand. Or, okay, now listen, do not delete a column, but you can clear a column. So if you go up into the heading and hit clear enter, it will clear the whole column at once. Does that make sense? So don't use delete here. You will actually delete the column and L3 will cease to exist.
It's okay, you can put them back.
You can put it back. That was already experience. I'm glad you figured out how to put them back because it's been a bit and I can never remember how to put them back when people lose. Fun. So you go clear, enter, and it will clear the whole column. L2, clear, enter. L1, clear, enter. Now, I'm going to type in some data, yes? In L1, I'm going to put in my times. So L1 is going to be these. L2 is going to be the distance traveled. Get those entered. L1 was fun. Okay, get your numbers in because I really don't want to proceed until everyone has numbers in. So now what we're going to do is we're going to graph these numbers. And I guess when I say graph these numbers, we're going to graph these points, yes? So we're going to graph the point 0, 0, 1, 0.75, 2, 3, 3, 6.75, yes? So in order to do that, we're going to use something called stat plot. This means I have to turn my stat plot on, first of all, which I will tell you, if you don't remember to turn off later, it can become an issue and it does cause errors sometimes. So, if you notice stat plot, some of you guys have probably accidentally played with stat plot. Stat plot is above the y equals, yes? So I'm going to go into stat plot, which means I'm going to do second and my y equals button. You'll notice right now, plot 1 is off, plot 2 is off, plot 3 is off. I'm going to turn plot 1 on. So, right now I'm on 1, I'm going to hit enter and go into 1. And right there, where off is the one that's highlighted, but I'm flashing on, I'm going to click on. And now my on is highlighted. Now, you can actually change your type of graph. we're just going to leave it on the first one right there. Because you can do other types of graphs here. But you need to pick your X list and Y list. If your values are in L1 and L2 like me, you can leave it as is, yes? So my values, my X's, my elapsed time, right, which are basically my X's, were in L1. My distance traveled, basically my Y's, are in L2. If, for instance, you deleted L2 and you don't have L2, and so yours are L1 and L3, you can change that right there, right? So that's good. You can change, if you're fancy, you can change what type of marks it makes. You can change the color. Okay.
I can't.
Now, if you hit
I know, that's
graph, okay. At this point, we're ready to go to a graph. With that in mind, first of all, do you have anything already on your graph?
Mine is black.
Okay. So if I hit graph right there, you see I have some dots. Starting at 0, 0, and going up. And that was just, I just hit graph. That's all I did. I went straight to graph. Now, I don't know, what did you graph last? Is your graph really zoomed out or zoomed in? Do you maybe need to do a zoom 6? Remember that Z standard? So that might help. Now, do you have lines going through your graph? Did you maybe graph something and not clear it out? So if I go into my Y equals button, if there's anything there, I would want to clear that out. Okay? Now, can I see all of my points?
No.
No, I can't. And so at this, think about, this is where I'm not going to try to zoom. I'm going to use my window. My X values, to see all of them, I need to go from 0 to 8. So 0 to 10 is, good. My Y values, though, they need to go from 0 up to at least 48. So like 0 to 50. So this is a good thing. So if you go into window, remember window is where you can change this. If I go into window, do I need to see any negatives? No. I'm going to change my X min to 0. My X max, it went as high as 8, so 10 is good. Don't worry about X scale. Y min, do I need to see negative Y's? No, so I'm going to do 0. My Y max, I need to go above 10 if I want to see all my points, don't I? I'm going to use 50. And after you get that changed, you can hit graph and take yourself back to the graph.
Whoa.
And now,
So cool.
I can see all 9 dots, and it's more zoomed in. I can see the whole graph thing. And Kylie and Sophie's are magenta.
And mine are- and mine-
Mario's.
and
I
mine.
changed
Mine
mine
is
to
blue.
magenta on
Mine is black.
Now, right, not all calculators can change color.
Well, I mean, mine
So-
can't change color.
It had a light.
Okay,
Okay.
there were different options. Now,
It's just
have we made progress? And are you making any progress back there and figuring stuff out? Awesome. Okay. You got it? Okay. Now, I'm obviously going to get interrupted, of course. But, so we'll have to totally finish this problem on Monday, but hold on, I'm not done. Thoughts on the shape of that graph?
It's like a, what's it called?
It has a.
Say, what's that word?
No, what's the word? Because it's like a half parabola. Something like
Okay.
that.
Does it kind of look like a half parabola?
Yeah. I just can't
Okay.
remember what it's called.
Just a parabola. I don't have a more specific word, right? So, what we're going to look at here is the fact we'll look at Monday because we want to come up with an algebraic model here. This looks like a quadratic function. It looks like only the positive half, but that's because we have positive numbers. So this is what we are going to call a parabola. And what we're going to do is we're going to create an equation for it. I'm just going to have to wait and do that Monday. Okay?
Tuesday.
Valid point, Tuesday.
Mario, you were gonna come to school.
I'm going to skip Monday, and I will take it on Tuesday.
Mario didn't
It
realize
has
it
a
was late today
positive
until like
velocity
Wednesday.
and then a
And he
constant.
was like, what about school?
Good job, Sophie.